Hello everyone, this is Maggie. Today we're going to see a question in kinematics and how to solve it. So the question says a motorist drives along a straight road at a constant speed of 15 meters per second. A police officer starts to accelerate at 2 meters per second square to overtake the motorist. What time takes the officer to reach the motorist? So what we have to know here is that the motorist here has a constant speed of 15 meters per second. So we can see from this that the motorist's motion is uniform motion. As for the police officer, it says it starts to accelerate at 2 meters per second square. So it's an accelerated motion, and we don't have an initial velocity here, so we assume it to be zero because it just says start, and we just have an acceleration of 2 meters per second square. So the question here is to overtake the motorist, what time it takes the officer to reach the motorist. So what we're going to use, the concept is the distance of the police officer is equals to the distance of the motorist, because it says here to overtake and it says here to reach. So if the police officer is to reach the distance of the motorist, it must move, or it must cover the distance of the motorist. So the concept here is the distance of the motorist is equals to the distance of the police officer. And by doing this, or by using this concept, we can find the time taken to reach the motorist. So our given again is a velocity of the motorist, which is 50 meters per second, acceleration of the police officer, which is 2 meters per second square. And our concept here to use is the distance covered by the motorist is equals to the distance covered by the police. And our required here is the time taken to cover the distance, which is the distance covered by the motorist. So what we're going to use is the distance equals of the motorist must equal to the distance moved by the police officer. We use the equation of uniform motion for the motorist because it has a constant speed of 15 meters per second. So the distance of the motorist is equals to v times t, velocity of the motorist times time taken by the motorist. And here for the distance of the police officer, we use the uniformly accelerated motion formula, which is u times t plus 1 over 2 or 0.5 times a times t squared. A is the acceleration of the police officer, t is the time taken by the police officer. So, as I said before, we're going to assume that the initial velocity of the police officer is going to be 0. So 0 times t is going to be 0. So we're just going to use this formula, which is 0.5 a times t squared for the distance of the police officer, and we're going to use a formula of v times t for the distance moved by the motorist. So when we equate this two, we get vt equals to 0.5 times a times t squared. A is the acceleration and t is the time square. So v equals to and then we divide both sides by t. To get t by this side, we divided by t, we divided by t. So when we do that, we get this, which is v in the left side equals to 0.5 times a times t, because we have divided t squared by t, and when t squared divided by t is going to be t. So when we rearrange this formula, we get t equals to 2v over a, which is v is the velocity of the motorist and a is the acceleration of the police officer. So we just substitute the velocity of the motorist with 15, because we have a given of 15 meters per second for that, and for the acceleration we use 2 meters per second square. So 2 times 15 is going to be 30. 30 divided by 2 is going to be 15, so we get 15 second. Okay, how do we get the second? Because we have a velocity of meter per second, meter per second, I'm sorry about my handwriting, meter per second divided by meter, I'm sorry again, divided by second square. We get equals to a second here. When we divide this by this and this by this, we get, which is 1 over second minus 1, which is equals to second, because 1 over second, the power of minus 1 is going to be second. So guys, thank you for seeing this video. I hope you like and subscribe it.